Hello my dear students, how are you? I hope you are doing good and you are safe in your house. In the previous lectures, we discussed about the mole concept and concentration terms. Now in this unit, in this class, we will discuss about the stoichiometry. What exactly is the meaning of stoichiometry? What do you mean by stoichiometry? How to define the stoichiometry? What are the uses of stoichiometry along with the limiting reagent? You know, when a chemical reaction takes place, it is not necessary that all the reactants consume simultaneously. So what is the limiting reagent and how it plays the important role deciding what factors, right? So these are such calculations that we shall discuss in this lecture. So let's continue.
Stoichiometry and the limiting reagent. Let me tell you something about the stoichiometry. Students, stoichiometry is very important for any chemical reaction. In the chemistry, you would be able to solve very difficult numericals if you have very strong command over the stoichiometry and the limiting reagent, and also it is very basic and fundamental. Alright, so in today's class we shall discuss about the stoichiometry in detail and also about the limiting reagent. So what concepts we shall discuss in this class is the introduction of stoichiometry, then stoichiometric coefficients and the stoichiometry, general stoichiometric steps, mass relation of the stoichiometry, mass volume relation of the stoichiometry, volume relation of the stoichiometry, and also limiting reagent. These are the topics which we have to discuss in today's session. So we start with the stoichiometry. What is stoichiometry? From where this word came? Jeremias Benjamin Richer, he was from Germany and he was the first scientist who used the term stoichiometry in the chemistry. The whole number, what is stoichiometry? It is the whole number representing the moles of the reactant and the product involved in the reaction, or you can say in the balanced chemical reaction. They are the stoichiometric coefficient. It is very easy. Suppose, say for example, if I write the reaction of Haber process, which is nitrogen plus 3 hydrogen gives twice of ammonia, and 2 plus 3H2 gives 2NH3. Now in this reaction, first of all you check whether the reaction is balanced or not. Yes, this reaction is balanced. 2 atoms of nitrogen, here 2 atoms of nitrogen, here 6 atoms of hydrogen, in the product also 6 atoms of hydrogen, so the reaction is balanced. Now in this balanced reaction, coefficient of nitrogen is 1, coefficient of hydrogen is 3, and coefficient of ammonia is 2. So this 1, 3 and 2, this is the stoichiometry of this reaction. If you take another example, dissociation of calcium carbonate. Guys, when calcium carbonate undergoes dissociation, it gives calcium oxide plus carbon dioxide. This is solid, and gas. In this equation, all were gas. So now this is a balanced chemical reaction for the decomposition of calcium carbonate. In this reaction, coefficient of calcium carbonate is 1, coefficient of calcium oxide is 1, and coefficient of CO2 is 1 as well. So this is the stoichiometry of this reaction. If I see the reaction for the formation of water, H2 plus half O2 gas, H2 gas plus half O2 gas gives, say, H2O liquid. So in this reaction, first check whether it is balanced. Yes, it is a balanced reaction. Coefficient is 1, half and 1. So this 1, half and 1, this is the stoichiometry of this reaction, and this 1, half, 1, they are the stoichiometric coefficients. Alright. So stoichiometry deals with the relative quantities of reactant and product. Suppose you have quantity of one reactant and you just wanted to know that how much quantity of, say for example, any product will form in chemical reaction. You can do it with the help of stoichiometry. And stoichiometric calculations are based on the fact that atoms are conserved, means they can neither be created nor be destroyed. You cannot create atom, you cannot destroy atom. What does it mean? If I elaborate, it means the total number and the kind of atom. Two things: number, how many number, what is the number, and the kind of atoms before and after the reaction are always the same. Number of atoms before the reaction and number of atoms after the reactions are always same. And this is also the basic law of nature. So basically stoichiometry is based upon the most basic law of nature, right? Say for example, this is the reaction in front of you. One more reaction is there. Zinc plus 2HCl gives ZnCl2 plus H2. This equation gives a complete information about the reaction under consideration. Now it tells you what? The given equation, you see the stoichiometry is 1, 2, 1 and 1. But one more time I'm telling you, before you check the stoichiometry, always check whether reaction is balanced or not. If it is not balanced, there is no mean of stoichiometry. You can always talk about stoichiometry only if reaction is balanced. Now it tells you that 1 mole of zinc, here 1 mole of zinc reacts with a 2 mole of dilute HCl. 1 mole of zinc reacts with a 2 mole of dilute HCl and they produce 1 mole of zinc chloride and 1 mole of hydrogen gas. So in this reaction, what are these stoichiometric coefficients? They are 1 for zinc, 2 for HCl, 1 for the ZnCl2 and 1 for hydrogen. So now I hope you are getting what do we mean by stoichiometry and stoichiometric coefficient. These stoichiometric coefficients are useful since they establish the mole ratio between the reactant and product. Are you getting meaning of this point? Suppose you have to establish a relation between two different reactants or two different products or one reactant and one product, that how much amount of reactant will consume and how much amount of product will form. So stoichiometry is very important to study the reaction, to get the amount of product and the remaining amount of the reactant. And stoichiometric ratio is the simplest whole number ratio of the moles of the reactant and also the product involved in a chemical reaction. I gave you plenty of examples to understand what is the stoichiometric coefficient or ratio. In the balanced chemical equation, as I told you from the very first moment, that stoichiometry or any calculation of the stoichiometry is useful only when reaction is balanced. So it gives you the quantitative information. Stoichiometry is not about the qualitative information. You know guys, what is the qualitative? Qualitative is the content and quantitative is the amount. So basically it gives you the information of amount. How much amount of reactant is being consumed? How much amount of product is being formed? So stoichiometry is all about the quantitative information, quantity, not the quality. We have three kind of relations which we use in the stoichiometry. One is the mass-mass relationship. Students, in the mass-mass relationship, we predict the mass of another reactant with the help of the mass of given reactant or the product, whatever. The another relationship is the mass-volume relationship, number 2 relationship. This was the number 1 relationship, mass-mass. Number 2 is the mass-volume relationship. Here what we will do, mass of any one reactant or the volume of any one reactant or product will be given and the another quantity of any other reactant or product will be asked. And the last relation is the volume-volume relationship, in which very simply one volume will be given and another volume will be asked, maybe of reactant or maybe of product. It depends upon question. So first we will discuss mass-mass relationship. What is mass-mass relationship, students? In this type, mass of one of the reactant or the product is given and mass of some other reactant or product is to be calculated. I'll give you the examples to explain this one. Say for example, in this equation, very simple equation, N2 plus 3H2 gives twice of NH3. Now if I ask you what mass of NH3 ammonia will be produced by 14 gram nitrogen. Now suppose you have 14 gram nitrogen. Suppose you have, what you have is 14 gram of nitrogen, and you have to find out what mass of ammonia can be produced. So first of all, you will check the stoichiometry 1, 3 and 2. Now it is clearly visible that 1 mole of nitrogen will give 2 moles of ammonia. Here 1 mole of nitrogen will produce twice of mole of ammonia. Now everybody knows then 1 mole of nitrogen is 28 grams and twice of mole of ammonia is 34 gram. How 34? Molar mass is 17 and we have 2 moles. So 34 gram. So now I will say that 28 gram nitrogen can produce 34 gram ammonia. So 1 gram of nitrogen can produce, my dear students, 34 upon 28 gram ammonia. What about 14 gram nitrogen? Students, so 14 gram nitrogen will produce 34 by 28 into 14, which is equals to 17 gram ammonia. So answer of this question will be 17 gram. Now in this, we have been given the mass of one reactant and we calculated the mass of another reactant with the help of stoichiometry, right? If I take the another example, now I'll give you the another example of some other different reaction. Now suppose the reaction is N2 plus O2 gives twice of NO. All of them are gas. Now it says 1, 1 and 2. Now what is the question? By 8 gram oxygen, how much nitric oxide can be produced? It seems little bit difficult, but with the help of stoichiometry, it becomes very easy. What stoichiometry says? 1, 1, 2, which means 1 mole of this reacts with the 1 mole of this and produce 2 mole of this. What is the molar mass of oxygen? Molar mass of oxygen is 32 gram. So I will say 32 gram oxygen will give, what is the molar mass of atomic mass of nitrogen? 14, and atomic mass of oxygen, it is 16. Molar mass will be 30 and 2 moles will be 30 into 2, which is 60 gram. So now as per the stoichiometry, I will say 32 gram oxygen gives 60 gram nitric oxide. So 1 gram oxygen will give 60 by 32 gram nitric oxide. Now what about 8 gram? 8 gram oxygen will give, 8 gram oxygen will give or will produce 60 by 32 into 8 gram NO, which is 15 gram. So this will be your answer. By using 8 gram oxygen, how much nitric oxide is produced? Students, the answer is 15 gram. So this is how we solve the questions of mass-mass relationship. Now the another relationship is mass-volume relationship. What happens in this mass-volume relationship, students? It is also very easy. In this type, mass or the volume of one of the reactant or product, whichever, is given, and the mass or volume of the other is to be calculated. So in this relationship, mass of one reactant is given and volume of another is to be calculated. But remember, note, this relationship is valid It is valid, but it is valid only for gas at STP. For volume, in terms of volume, it is valid only for gas at STP, right? Let me give you the example. Again, if I choose the example of Haber process, N2 plus 3H2 gas gives twice of NH3 gas. Stoichiometry is 1, 3 and of course 2. Now if I ask with 4 gram hydrogen, what volume of NH3 ammonia can be produced at STP? Now you see, mass of one reactant is given and volume of ammonia is being asked. So what is given is the mass and what is asked is the volume. Again, I will use the stoichiometry. It says 1 mole of nitrogen reacts with a 3 mole of hydrogen, which produces 2 moles of ammonia. Very simple. Now we know for hydrogen mass is given. So I will convert these 3 moles into mass. Molar mass of hydrogen is 2. So we know that 3 moles of hydrogen will be equivalent to 6 gram. So 6 gram H2. And for ammonia, volume is asked. So I will convert the moles of ammonia into volume. We know that 1 mole of any substance at STP is 22.4 liter. So 2 moles will be 2 into 22.4 liter volume, which is equals to, my dear students, 44.8 liter. So by using 6 gram hydrogen, you can produce 44.8 liter ammonia. Now I will use the unitary method. 6 gram hydrogen can produce 44.8 liter ammonia. 1 gram of hydrogen can produce 44.8 by 6 liter NH3. And what about the 4 gram? 4 gram hydrogen can produce 44.8 divided by 6 into 4 liter of ammonia. So this will be 44.8 into 2 by 3 liter volume of ammonia. This is the volume of ammonia will be produced by 4 gram of hydrogen. So this was about the mass volume relationship. Now the last one is volume relationship. Now I hope you're getting what is volume relationship. In this type, volume will be given of what? One of the reactant or product, whatever, and volume of the other reactant has to be calculated. So volume of one reactant will be given and volume of other reactant you have to calculate. This is the volume relationship. All right. So I'll give you the one example of this also. Again, if I choose the example of a Haber process, N2 plus 3H2 gives twice of NH3. I'll ask what volume of hydrogen will react? What volume of hydrogen will react? 5 liter of N2. Now both of the data is for reactant. Volume of one reactant, that is nitrogen, is given, and volume of another reactant, that is hydrogen, is being asked. As per the stoichiometry, which is 1, 3 and 2, I'll simply say, I'll start with the mole. 1 mole of this react with the 3 mole of this and produce 2 mole of this. Alright. Now 1 mole of this is 22.4 liter and 3 mole of this is 3 into 22.4 liter. We don't want any information of ammonia, so we will not use for the ammonia. And what I will say now, I'll say 22.4 liter nitrogen reacts with 3 into 22.4 liter hydrogen. So what about 1 liter? 1 liter nitrogen will react with 3 into 22.4 divided by 22.4 liter hydrogen. And what about 5 liter? So according to this calculation, 5 liter nitrogen will react with 3 into 22.4 divided by 22.4 into 5 liter hydrogen. That is 15 liter hydrogen. So 5 liter of hydrogen, so it will react with a 15 liter of hydrogen. This is the right answer, students. All right. Now the next point of discussion is limiting reagent, which is the last topic to be discussed in this unit, mole concept. Limiting reagent. As the word says, limit. In any chemical reaction, when a chemical reaction takes place, the reactant that is entirely consumed and limits the amount of product in the chemical reaction is called as limiting reagent. You know, students, when a chemical reaction happens, we take the initial amount, and it is not necessary that we take the initial amount in the ratio of stoichiometry. We can take the initial amount which is something different than their stoichiometry. Say for example, in any reaction, if you take the initial amount other than stoichiometry, any one of the reactant will consume prior to others, which is called as limiting reagent. And now, how to calculate the limiting reagent? Suppose you have two different reactants and you have to find out which one is limiting. In simple words, you can say the reactant which consume first is limiting. So suppose you have two different reactants and you have to compare which one is limiting. So you can use this formula. Moles of the reactant 2 into coefficient, stoichiometric coefficient of 1, reactant 1, divided by the stoichiometric coefficient of reactant 2 minus moles of the reactant 1. Whatever the amount of number of moles of 2 multiplied by coefficient of 1 upon coefficient of 2 minus moles of 1. Now what are the possible outcomes? When the answer is less than 0, if the answer is less than 0, which means negative, reactant 2 is limiting. When the answer is more than 0, which means positive, reactant 1 is the limiting reagent. And if in case answer is 0, which is also a possible outcome, means both the reagents are perfectly balanced and no one is limiting, means both the reactants will consume simultaneously in this reaction. So this is how we find out the limiting reagent, students. And this was all about this concept of stoichiometry and limiting reagent. I hope by this lecture you understood the concept of limiting reagent and stoichiometry. This was all about this. Please keep watching and keep studying. Good luck to you.